So if you've seen this guy before, you are probably going to like this video. This is a deep dive on Code Bullet and how he builds his algorithms on his YouTube channel. He's a YouTuber that builds games like Snake, Tetris, things like that. And he builds an AI to play the perfect game of Snake, Tetris, and things like that. So on today's video, I'm going to use his video, AI Learns to Play Jump King. I'm going to pull down his code and I'm going to unpack how he does it. And then at the end, we're going to build our own AI video as well, but we're going to prove the concepts of what he does. If you haven't checked him out, you have to watch Code Bullet. It is so funny and entertaining. So shout out to Code Bullet. So he's building an evolutionary algorithm on his Jump King game. Essentially, if you can see here, he builds these little mans that have to jump up to this ladder and then go to the next one. And this is him training the AI to play this game perfectly. And actually, we have the source code here for that game, Jump King, because it was uploaded by Code Bullet. So I'm going to show you how to pull this down and actually run this yourself. But anyway, I'm going to talk through the concepts of what the evolutionary algorithm is so you can build one yourself. Okay, so go to this link that will be in the description and copy this. So once you've cloned it down, then you can change your directory into that one. It's called Jump King. Yeah, and then we can use a code editor to open up the code. Okay, cool. So what I noticed is if you want to get this running yourself, like you just want to train the AI like Code Bullet did, if you go to the population.js, this is where all the saucy stuff happens. You can see here that it's got natural selection, calculate fitness sum, select parents. So this is where all the brains are. If you go to his code, you can see he's got this, these arrows. And this is where you can actually trigger the AI yourself. So if you uncomment all these ones with the arrows like this, and then delete the arrows, so this syntax doesn't complain, and check if there's any other arrows, which is no. You can go back to that page that you're serving and hit refresh. Oh, nope, there's something else. Okay, I found it. So you also need to go to sketch.js, and then there's this variable called testing single player. And this is like a mode that you can switch between playing it yourself and then triggering the AI to start running. So let's change that to false, save it, and see what happens to our page. Whoa, look, this has fired off the AI. So you can see here that there's a generation marker, there's a number of moves, so each one of these players in the population is doing 5, and it's finding its best height. So Code Bullet goes through how he determines this. So if you're unsure about this, definitely go and watch his video, and then we will get back to building this ourselves. You can see here that that guy's made it up, which is cool. And then it goes to the next level. So once the AI has solved the first level, you can see here that it's starting to train the next level. So in his video, there's probably like 40 minutes of this going through the entire levels. I think there's like 40 levels or something like that. So it's really cool. But this is it working yourself. But now we're going to build our own. It's going to be really simple. It's not going to be this nice game that Code Bullet has built. Like I said, it's going to be something really basic in Python. But anyway, that's the point. Let's get to it. Okay, open up your own terminal and let's make your own directory and call it console AI. I don't know, whatever. Cool. And let's open up VS Code. Okay, let's build our own game. And it's probably useful to explain what we're going to do first. So, in a random text file, we're going to make this really, really simple. We're going to have a grid of like, this is point 0 to 0. And over here, this is point 10 to 10. So you can see here that it's like a 10 by 10 grid. And at some place in this grid, we're going to have a marker, which will be ourselves, and we can move this around with our arrow keys. So it's kind of like the previous player moving around the game in Code Bullet, but we're just going to do this on a really simple console ourselves, so we don't have to build all of the characters and the assets and things like that. So, and then this marker can move around the page, and then there'll be some target like here. And this target will have something like this. Like this target will have some coordinates, which is probably, I don't know, that's like 2 and 8, for example. So go across 2 and then go down 8, and that's the target. So we're going to know the coordinates of our cursor, and then we're going to know the coordinates of the target. We're going to give it random moves to see and to train it to reach the target. So that's what we're going to build. And this is why I chose cursors, because it's probably a pretty simple way to get this game running up, get this game up and running pretty quickly. So let's build a game. So we've imported cursors, and then we need to build the window. So this isn't going to go too much into how cursors works, because that's not the point of this video. So I might like brush ahead on some of the concepts of cursors, but that's okay. So once we run this file, this is what we need to do. We need to create a screen, and then in cursors we need to initialize the screen. And then we need to create a window, and that's the window where our game will be. So cursors, new window. And then let's set a variable called lines, which will be 10, and then columns, which will be 20. So this is like the X and Y of lines and columns. So this is like the X and Y of our window, game window. Okay, then what we'll do is, now we've created those windows, and I've just done it like this, so these are globally scoped because we'll use them across the across the script. So let's create a main function, and in that main function we want to be providing, we want to be running a game of some sort. So let's call another thing called run game. So when we call main, we'll run the game, and then we'll create another function called run game. And so in run game, what we want to do is window.keypad.1. This is a cursors thing. This is saying take keypad or keyboard inputs. Cursors, set cursor. So this is going to set the cursor at 0, 0 coordinate. And then we want to hold the window open. So while true, we'll set some other properties. So give it 0 border, give it some timeout. And then we just want to add some characters. So this is add string to the board, and this will be the position of our cursor. So let's just give it like some random coordinates for now. And then we want to give it the position of our target. So let's say our target will be this, and let's just globally put our target here. So our target coordinates will be maybe like 5, 5. And again, this is just random. We're just setting the game up still. Okay, let's move that to target. Cool. So what we want to do is we're going to try and get the key input. So this here is getting the key input. So when this is get char or character. So when the keyboard receives a character, this is the key that it received. And then we can say if key is key left, cursors.key left. Let's just go move left. And let's do this like this, key right. key up, key down. This is pass for now. Okay, cool. So we're just setting up the basics of the game. So this will do a while loop, so it's continually checking. And so if there's no key pressed on the keyboard, this will actually be -1. This is just how our cursors works. You don't have to worry about too much. But if there's no key input, the point about this is if there's no key input, we want to continue and keep looping. And let's see how this works. So you can run Python main py, and I haven't called run game. Okay, there's our dashboard. It's a little bit mucked up, but that works. So now what we want to do is we want to build the star. Okay, so we want to build the cursor on our game. So we can do that. What we'll need to do is create our star, and we're going to create a new class. So let's create a new file. Let's call it star. Star or cursor, same thing. You know, it's synonymous. So first of all, let's import cursors again. And let's define a new class and call it star. And then when we instantiate the object, we're going to give it an initial x, an initial y, and the window of our game. We'll set self to x, x, self y, y, and self window, window. Cool. And when we render the star, we're going to attach it to the window. So self.window, add character to the position of self x and self y, and we'll give it the character of a diamond, because why not? We're also going to want to get the position of this, because this is going to help. So the position of this will be a tuple of x and y. And let's give this a property. So it has, so this sets a getter for this property for this this object. Cool. And while we're here, let's do the move left and move right as well, just so we can code this out and then get to the good stuff. So if self.y -1, so if this is close to the border, when it's moving left, let's not move it. Otherwise, let's move it on the window. So self.window add char, the current position, self x, self y. Let's remove that character with an empty character, and then actually move it one space, and then render the space that it just moved into, so self x, self y, to the cursor character, to the star, or the diamond, or whatever. So this is our move left function. So let's save that. And then in our star, we have to import from star file, Python file, import the class star. Then we can instantiate star. And let's just set this up to something something default, like we could set this up to 6 and 10. And we have to provide it the window as well. Cool. And then we want to render the star on the window. So let's see how this looks. Okay, there's our position and there's our target. And if I am touching my keyboard, nothing is moving. Okay, something is broken. Let's fix that. Of course, we're not actually moving the star left. Star move left. Delete that. Let's see how that goes. Cool. So I'm moving left, but I haven't done up, down, left, right yet. But you see it doesn't move beyond the window, which is awesome. So let's implement those other ones. So the same thing is true. I can just quickly move these around because. So move right. What we want to do is y plus 2 is greater than our columns, which I know is 20. Remove that, add that, and then attach. Remove, move up is we want to make sure that the current position -1 is 0. We want to do nothing because it's hit the boundary. Otherwise, we do want to move it, and we want to move x -1. Cool, and then move down. So if x plus 1 is greater than lines, which is 20. Do nothing, otherwise x plus 1. Okay, let's see how that works. Oh, of course, I have to implement this. Start up, move right, move up, move down, down. Up, down, left, right. Awesome. Cool. So that's the position of the target. So now we're trying to render the target. So window.add character. Target 0. Target 1. And let's call it a block. Cool. Let's run that. Okay, we're moving our player, and then we reach the target. Okay, so that's our game. So what we've built here is a small console game, and it's nothing like the one on Code Bullet. I totally get that. But the point is, we're going to then, I'm moving this with my keyboard, we're going to then give it inputs or give it instructions to move, and we're going to use this evolutionary algorithm to train it so it can train itself to be in the final position as the target, like this. And we will do a scoring mechanism. So if the dot ends up all the way over here, that will have a bad score. And then if it ends up closer, like here, that will have a good score. And then we're going to use that generational, or the iterations of the generations in the evolutionary algorithm to train it. So this is the fun part. So let's get going. So how this is going to work is we're going to provide the game some instructions. You can see here that it's taking my input, but we want to provide it some, random instructions. And then we're going to run the game. And then after the game, we're going to capture a score for those instructions. And then we're going to do that multiple times. So if I pass 10 lots of random instructions, I'm going to be able to capture the best score. So at the end of the game, I'm going to have, the best set of instructions for 10 random ones. So the best set of instructions within the 10, right? The whole point of the evolutionary algorithm is you take the best, you feed it back into the top so that your random instructions is actually is kind of like a function of the best set. So instead of being completely random, it's like you take the best set of instructions and you randomize that a little bit, and then you run that through the same system. So it's all about first making your instructions random, getting a score, get the best score, take those instructions, put it back into the top, and then tweak them a little bit and find like randomized versions of that. And then slowly your algorithm will keep iterating until you have a score that's considered good enough. after all of that, we might do that 100 times. So 100 generations, right? And at the end, we have a score that's good enough, or that we determine is correct based on our game or based on what we want to achieve. And then, boom, that is evolutionary algorithm working. And this is actually how Code Bullet does it as well. So if you go back to Code Bullet, again, I don't want to really unpack the code, but this is what he's doing. He's saying, when it's time to do the natural selection, which is just fancy dialogue for capture the best score and the best set of instructions. That's the same thing. So he's saying, capture the best score, delete all the ones that don't have a good score, and just use the ones that do have a good score. And then from there, you can basically use that next gen and push those best score ones onto the next time it iterates. And so you're actually iterating your instructions over and over until suddenly the score becomes, bigger and bigger, or lower and lower. And that is the essence of it. So this is all that Code Bullet is doing. This is an evolutionary algorithm. It doesn't include things like machine learning or Q-learning or all of that sort of stuff, which I sort of thought it was in the video. But after looking at this, it's actually quite simple, right? It's quite elegant. It's the concept of it, the concept of the evolutionary algorithm, which is what it is. Okay, so to start, we're going to create a set of instructions, right? So this will be an array of keyboard inputs. So the keyboard inputs we're going to use is 26, 258, 261, 259. So don't get too confused. This is just the cursor's way of saying key up, key down. So in fact, I could actually do this, and I might do this. That's actually perfectly fine. Like this. And then a no move would be -1, right? But let's just do this for now. So this is the set of inputs that we're going to allow this game to have. And then from these inputs, we're then going to build our first set of instructions. So let's call them instructions. And then let's random choice of inputs for item in range. So this will create a list of 20 items of these inputs randomly, right? And then we're going to provide those instructions to the game. So once we do that, let's save and let's send the instructions there. And then now let's make the game listen to the instructions. So firstly, what we want to do is, if the length of instructions equals 0, we want to return the star, saying there's no more instructions left. Finish the game. Next, what we want to do is take the key. So key instructions. So we want to pop an item off the list, and we're going to take that one key. It's like an input. So let's just rename this as like -1 for now. And then I think that's it. Yeah, so based on all the instructions, we're going to take one off the list, and we're going to move the cursor based on whatever's in that list. So I'm pretty sure that's it. So let's just test that. So let's just run the game. And look, random instructions, and the game ends. And if I run that again, you can see it's sort of moving in different ways. Oh, and I was much closer to the position then. And if I run it again, so it's creating random games. So that's one set of instructions playing this game. Now we want to do is to do that iteration thing I was talking about. So we want to create multiple ones. Okay, before we start iterating, we do have to somehow score in this step. We have to somehow score that game. So we can do that by adding a function or a method to the star and call that get score. So the score is going to provide something like, if the block is here and the star is here, that might be, for example, 5 steps away. But if the block is here and the star is here, that score might be that star's only 1 step away, so the score might be 1. And if the block and the star are on the same point, that score is going to be 0, as in we've found that point. So if the star ends up on the block at 0, that's like game 1, right? So we can do that by just finding how far away it is, how far the star away it is from the target on the X, and how far it is from the Y direction. And then we can return X factor plus Y factor. So if the position of the star is exactly on the target, this will be 0, and the same for Y. So 0 plus 0 will be 0. So a perfect score will be 0, and anything else will be an integer above, saying that the score is worse, so it didn't perform as well. So now when we run the game, we're going to have the star, and we're going to be able to get the score of the star. So an example of that will be current game score, which is equal to star get score. And we have to give it our target, which is just some random number that we've provided at the top. We can change this later. Okay, so to make this work, we need to start iterating this game. So from the inputs, we need to determine an initial best score and set this to something quite high, and then initial instructions. So let's call this best instructions, and you'll see why I do this. I'll do this in a moment. Okay, let's put the current game score to something like 1,000 as well. And then let's put a generation counter. So this is going to show us the number of generations that we're using. So while the best score is greater than 1, so if you remember how we're scoring things, we're only scoring things where 0 is game 1 and anything higher is not the best score, right? Anything like higher, like to 5, 10 is actually worse. So while we don't have the best score, so while we don't have our score as 0, because that would mean game complete, let's run the algorithm. So let's create a list of results, and then let's run the game 5 times, like this. So what we do is, with our best instructions, we actually provide some additional random points. So what we're doing is saying, for the 4th step in the set of instructions, randomize that point. And we'll just do that randomly, like we'll do this for the 8th step and the 12th step and the 15th step. So as the instructions come in, remember this will be iterated upon. The first one will be completely random, and then we'll randomize some points and we'll run the game. But at the end of the game, remember how we said that we're going to choose the best one, so that then we're going to change the variable so that the next one that is looped will actually be a better score based on, will actually be the best score within that loop. So let's keep going. Instructions. So this is just making a copy of the instructions because we actually pop it off in this function. Save instructions, instructions.copy as well. And then, so this is just copying so we can actually capture this. So saved instructions. Okay, cool. And then that's the current game score. And so we've got that for that game. And then we can append the results. So we can append the current game score with our saved instructions. Right, that makes sense. So for these instructions that ran in the game, this was the score. So we're going to do that 5 times. And at the end of the 5 times, we're going to find the best results. So the best results, or maybe we could make them sorted results. So sorted the results based on the value, the descending value of the item. So this will just sort the results array and have the lowest game score first and the highest one last. So the lowest one, so the first one will actually be our best one, if that makes sense. Cool, so actually the current best score is the first item in this array. So the first item in this array and the first entry point, which is the score, which will be this. And then we'll say, if this current best score is less than or equal to best score, then we have found a better set of instructions than the previous one, right? Because remember, the best score starts at 1,000. So the first one will definitely be a better score because we don't have a 1,000 wide grid. So only if we found this set of instructions better than the previous one, then we'll say, okay, let's update our instructions with this one. So let's set the best score being the current best score. So we're always decreasing that value. And then let's set the best instructions to the, our sorted results. So that's the first item and then the first item. So that's the key there. That's the whole point of the evolutionary algorithm. We've found the best score for these set of instructions. We're going to reassign it here. And then as this while loop returns to the top, and we haven't met our target score yet, which would be less than 1, we're then going to use those results, but only tweak them a little bit, and to keep changing them over time. And to keep tweaking them, if that makes sense. So we're getting this array of instructions, and we're tweaking them until we finally get our found score. So let's just put a counter here so that we can see this growing over time. And then let's render this to the window so that we can see what's happening over time too. So what was the best score for that run? And then in the second row, we could say, what's the gen counter? Cool. And then if our best score is 0, we've found, the algorithm has found the best set of instructions, let's return it to end the game. So let's just return best score and best instructions. Okay, now we're ready to run the game and see how it looks. So let's run it. Cool, so you can see here that the dots are showing that it's looping through that range, and it's providing a random set of instructions, and then at the end, it's recording it. So you can see here that the best score that we found was 7, and it was the first generation. So hopefully, those best instructions that we send to the top and then just randomize bits of it, hopefully over time, that will tweak itself to reducing that current best score down from 7 down to 6. Oh, look, it did it, down to 6. So you can see here that we're slowly manipulating those instructions, and hopefully over time, through those generations, we're going to get that cursor to land on that point. So this here is in essence of this entire video. This is what an evolutionary algorithm is. This is what CodeBullet does on his video, and this is how you can implement this yourself. Obviously, there's heaps to improve here. For example, this is probably not the best way to randomize the selected instructions or the natural selection. There's probably a better way. There's probably a better way to come up with a score. There's probably a better way to write this code even. The whole point about this was just to illustrate and demonstrate the concepts of the evolutionary algorithm, which I think is super exciting and super cool. And you can do this yourself. come up with an interesting game and you'll learn so much. Look, it just went from 6 to 5, the best score here. So it is working. I mean, it's been a few minutes now, and hopefully it gets there. It might not, but definitely it went from 7 to 6 to 5. So you can see here that slowly we're tweaking these instructions, and we hope that the program will end with with the dot landing on this block here. Also, you can see this is just a simple console game. There's not much else going on here, and it's not quite interesting like a Snake or a Tetris or Jump King with all the nice graphics and stuff. That's not the point about this video. The point is to talk about how you could implement this yourself. So taking these concepts, you would be able to go and build a much bigger, more interesting game than me for sure. So I'd love to see what you come up with. If you find this interesting, let me know what you found. And yeah, thank you for watching. If you're interested, I can post this code onto GitHub as well, so you can pull it down and start from here. And if you do that, let me know. That's really cool. I'd love to see what you come up with. And if you have an interest in machine learning, I'm thinking of doing more videos, but on actual TensorFlow, Q-learning, these types of things. So pulling down more impressive training models and how does that work and this sort of thing. So I really want to dedicate time to unpacking the algorithm, and so you can understand the concepts. And then from there, it's up to you to take it from a console game to a fully fledged UI and things like that.